We're on to lesson 11 of the organic chemistry series. So this one is now talking about the functional groups aldehydes and ketones. Now if you remember back to the introduction to functional groups, both of these functional groups contain a double bonded oxygen, right? And it's really just the location of the double bonded oxygen that is the difference between these two groups. If the double bonded oxygen occurs at the very last carbon in a chain, or actually might be better to think of it as the very first carbon of the chain, right? But it's at the end of the chain, right? Then it's an aldehyde, right? Whereas if the double bonded oxygen, right, occurs somewhere in the middle of the chain, so anywhere from the second carbon onward, right, then it's considered a ketone, right? But otherwise, the functional group is the same. It's carbon double bonded to oxygen, right? So I can represented the fact that this is at the beginning of the carbon chain by showing that it's connected to an H on one end and then to a carbon chain on the other. Whereas here, it's connected to carbon chains on both ends, right? Which puts this somewhere in the middle of the chain. Right? So the question is then, how do we go about naming these? Well, we really have all of the skills now that we need in order to name both of these, right? Really all we have to do is look at what is the suffix that goes on the end of the name to signify that it's an aldehyde, right, versus a ketone. And that suffix is very often in the name itself. So the suffix for an aldehyde is al, right? Not to be confused with ol, ol for an alcohol, right? If it ends in the letters al, al, then it's an aldehyde. And if it ends in the letters one, one, then it's a ketone. Right? So let's look at a couple examples. If I were to draw a carbon chain, right, and for an aldehyde, it has you can only put the double bonded oxygen either here or here. It has to be at the very end of the chain, right? Then there we have an aldehyde, right? And we can assume that, of course, because carbons have 4 bonds, right? We have 1 bond here, 2 bonds to the oxygen. There must be a 4th bond to hydrogen, right? But we don't always have to show our hydrogens, even though I've shown one here, right? So this would be an aldehyde, right? The double bonded oxygen is at the end of the chain, right? So what we do is we first say, okay, the main chain, right? In which case here there's only one chain. But if we have branches and that kind of thing, the main chain has to include the functional group, has to include the aldehyde. And because an aldehyde is always at the very end of a chain, right? The nice thing is the aldehyde carbon will always be carbon number 1. The aldehyde's always going to get the lowest number, and since it's always at the end of the chain, it's always going to be number 1. So we don't actually have to number aldehydes, right? It can be assumed that the aldehyde is always on carbon number 1, right? And then that makes this 2, 3, 4, 5, 6, 7, right? So this will just be hepta, right? And then instead of heptane, right, we're not going to put an E at the end to make it heptane. We're going to put AL at the end for aldehyde, right? So it's like the beginning of the word aldehyde. So it's heptanal, right? And that's what this is. This is heptanal, right? And of course, if we wanted to name anything with branches coming off of it, right? Well, the numbers are already there for us, right? And the numbers always start with number 1 on the aldehyde carbon, right? So I wanted to put in a propyl group here, right? So that's carbon number 1, 2, 3, right? Then all I have to do is say that that's on the 3rd carbon of my heptanal, right? So I can put 3 propyl heptanal. Right? So aldehydes are relatively easy. Again, like I said, I don't have to worry about numbering the fact that it's 1 heptanal, right? Because of course it's 1, right? If the double bonded oxygen were on any other carbon, right, then it would be a ketone, not an aldehyde, right? And of course it can't be 7 heptanal because the aldehyde has to get the lowest number, right? So if I were to move this double bonded oxygen over here, I'd have to reverse my numbering, right, in order to make this number 1. Right? Now, the ketones being in the middle of the chain, we will have to number, right? So I can start by drawing any carbon main chain, and then I can put my double bonded oxygen somewhere, right there. And now, because it could be anywhere, right? It's 1, 2, 3, 4, 1, 2, 3, 4. Let's add another carbon just so that it's not right in the middle of the chain, right? So is it 1, 2, 3, 4, 5, or is it 1, 2, 3, 4? Well, same rules apply, right? Not only does the ketone have to be part of the main chain, right, but it has to be the lowest number in the main chain. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, right? And so being an 8-carbon chain, this is going to be octane, and then instead of an E for octane, right, it's going to be O-N-E for a ketone. It's going to be octanone, right? And where is my ketone? Well, it's not on carbon 2, 3, 5, 6, right? It's on carbon 4, right? And so that's going to be 4, octanone. And of course, if I want to put a branch on this, right, the numbering has to stay the way it is, right? We always give the lowest number to the own, that's part of our main chain first. Then we worry about where the branches are after, right? So any branches that go on, I could put a branch right here at 7, right? And that would of course be 7-methyl hyphen 4-octanol, right? So even though, right, it's way down the chain, right, it still gets that high number 7, right, as opposed to a 2. It's only the second carbon from the end of the chain. It still gets the high number because if I were to reverse the numbering, making this a 2-methyl, it would increase this to a 5 for the octanone, right? And of course, we ignore the branches to begin with, right? We name the main chain with the lowest number for the ketone first, right? Then we number them, the branches afterwards.